Now we're going to create the unit circle. I'm going to try to do this quick. Pause it and watch it again, but I'll explain it as I do it. First of all, let's go degrees. That's got 0 degrees, and let's do 90-degree increments. That's 0, that's 90, that's 180. This here is 270, and then this is also 360. I'll move that to the inside so it's consistent. Alright, so that's degrees. And now let's also do, for the same thing, let's do radians. And the way I do radians, remember 180 degrees is pi radians. So going halfway around the circle counterclockwise is pi radians. This would then be half of pi radians because it's half of it. This would be 1.5 pi radians because you're counting going around. Here's 1/2, up here's half, whole, 1.5, 2 pi radians. Keep going around. You can keep going around, but we're not going to do that because this is only, the unit circle only has the one time around. We're not doing reference angles or that kind of thing, coterminal, all that kind of stuff. Alright, now I'm going to take the same concept and I'm going to do the orange lines. So this right here is, notice this is also would be considered orange. Orange is like splitting it up into 6 equal spots. See, I've got 1, 2, 3, 4, 5, 6. So dividing 180 by 6 gives me 30. So this right here is 30 degrees. Add another 30, you get 60. Add another 60, you get 90. Add another 30, you get 120. Add another 30, you get 150. Add another 30, you get 180. Add another 30, you get 210. Add another 30. Notice I'm skipping the green because I'm just going by 30s. You get 240, then you get 270 right here. Then you get 300 right here. Then you get 330, and then you get 360. Let's do the same thing but with radians now. Well, if I took pi radians and I had 6 of them, this would be pi over 6 radians because I'm dividing it by 6. This is 2 pi over 6 radians. Let's reduce it, which is pi over 3. This is 3 pi over 6, which is the same as pi over 2. This is 4 pi over 6, reducing it as 2 pi over 3. Here's 5 pi over 6. Here's 6 pi over 6. Here's 7 pi over 6. Here's 8 pi over 6, which I'm going to reduce that. 8 pi over 6 is the same as 4 pi over 3. 9 pi over 6 is the same as 3 pi over 2. 10 pi over 6, whoops, reduce that. 10 pi over 6 is 5 pi over 3. 11 pi over 6. And 12 pi over 6, which is the same as 2 pi. 0 degrees is also 0 radians, by the way. Alright, so there's my degrees for the orange. Now let's do the green. Again, for the green, notice this is also, the green is I'm taking 1 full pi and I'm splitting it up into 4 even parts. Or 180 degrees, dividing it into 4 even parts. So this is going to be 45 degrees. This is going to be 90. Add 45 to it. I'm going to write this out here. That's 135 degrees. Add 45, you get to 180. Add 45, you get to 225. Add 45, you get to 270. Add 45, you get to 315. Add 45, you get to 260. Do the same thing for radians now. I'm going to write the 45 out here. For the radians, I'm going to take, erase that. I'm taking a full pi and I'm splitting it into fourths. So this is 1/4 of a pi radians. This is 2/4, which is the same as 1/2. This is 3/4 of a pi. This is 4/4, which is the same as 1. This is 5/4 of a pi. This is 6/4, which is the same as 3/2. This is 7/4 of a pi. And this is 8/4, which is the same as 2 pi. Alright, that's how you do the radians and the angles. Now, for the measures of the side lengths, remember what I've got here is really, these are a bunch of this is called the unit circle because the radius is 1 unit. So this distance from here to here is 1. And if that radius is 1, and if this is 30 degrees in here, because that's what that is, 30 degrees, then you remember 30, 60, 90 triangle? If you had a 30, 60, 90 triangle, and if I put another one right next to it, and if I know this distance is 1, then this distance right here, notice this would be an equilateral triangle right here, because it's 60, 60, 60. So this full thing would be 1, which means this is 1/2. Across from the 30 degrees is 1/2. So let's look at this. What's the distance that I'm going right here? That's across from the 30. That distance is 1/2, which is the x or the y coordinate for this point right here.
Y coordinate.
That's the y coordinate. So 1/2 is my y coordinate, and also that, by the way, is your sine. That's your sine, because it's the opposite. The opposite is 1/2 over the hypotenuse, and the hypotenuse is always 1. So the sine is just 1/2. That's why the unit circle is a really good reference tool. And then if you remember to find this side right here, the other side, you multiply the smaller side by √3. If you remember that trick, it goes back to the Pythagorean theorem. I won't bore you with that. So this is √3/2. Well, if that's √3/2 1/2, then this right here, let me erase a little bit here. This right here is going to be the flip of that, because it's the same triangle, it's just on its edge now. So this right here's got to be 1/2 comma √3/2. It's just the flip of the two. And by the way, this over here is the same angle. It's the same triangle. The only difference is I'm going left. This is going to be a negative comma positive sign. So that point right there is negative. I'm taking these same values over here from the first quadrant. Negative √3/2 comma 1/2. And this one is negative 1/2 comma √3/2. And going around this one, notice these signs, the x is negative and the y is negative in this third quadrant over here. So all I do is I take that same thing, but now the signs are both negative. √3/2 comma negative 1/2. And same with this one right here. Negative 1/2 comma negative √3/2. And this one right here is a positive in the x direction, negative in the y direction. So it's a positive negative sign. All the values in the fourth quadrant are positive negative. So this value right here is going to be, it's the same as this one right here in the first quadrant. It's that 60-degree angle essentially. The reference angle is the same. So this is a positive 1/2 and a negative √3/2. And this right here, let me make some room for this, is a positive √3/2 comma negative 1/2. It's the same right there. I forgot to do the easy ones are obvious. This point right here is 1 comma 0 because you're going over 1 and up 0. This right here is 0 comma 1. This right here is negative 1 0, and here is 0 negative 1. Now let's do the greens and we'll be done. This value, these are the easiest because they're the same. It's a 45-45 triangle. 45-45-90 triangle. So these are both √2/2. √2/2. Whoops. Let me save some space here. Let's see if I can sneak it in. √2/2 comma √2/2. And this same thing, except the signs are negative. So it's negative √2/2 and then positive √2/2. This one right here, it's both the signs are negative, right? Because we're in the third quadrant. So it's a negative √2/2 comma negative √2/2. This one right here in the fourth quadrant is a positive and a negative because it's right and then down. So it's √2/2 comma negative √2/2. And there's your entire unit circle. Now if you need to find something, like let's say you wanted to find the sine of 7 pi over 4, you go to your unit circle, you look for 7 pi over 4, which is down in this bottom quadrant over here, and the sine is the second, it's the y coordinate, because it's the opposite, so it's negative √2/2. And the unit circle is a very quick way to refer to all of your very nice angles that have to do with either 90 degrees or 30 degrees or 45 degrees or anything like that. So all the reference angles there you can see. So obviously this is a pretty messy unit circle here, but you can find some nice unit circles and see all those values in there as well. So here's a nice picture of a unit circle, and you can see again, let me just point out to you, this right here, this triangle right here, is a 45, 45, 90 triangle. But the value is that this number right here, because remember it's called a unit circle because the radius is 1 unit. So what's the sine, for instance, of 45 degrees? Well, the sine of 45 is just going to be the opposite side of 45, which is the opposite side is going to be your y-coordinate because you're going up. That value right there, root 2 over 2, is right here. It's your y-coordinate divided by root 2 over 2 divided by your hypotenuse, which is always 1 because that's the radius of the circle, which is a unit circle. And so your sine of 45 is root 2 over 2. What's the cosecant of, let's say, 150 degrees? Remember, the cosecant is 1 over the sine of 150. So you go to 150, it's right there. You find the sine, which is right there. And you divide by that, which flips and becomes 2. So the cosecant of 150 is 2. Let's do another one. What's the tangent of 5 pi over 3? So we find 5 pi over 3. Remember, tangent is sine over cosine. So the sine is the y-coordinate, negative root 3 over 2, divided by the cosine, which is the x-coordinate, which is 1/2. Flip and multiply. Dividing by a fraction is the same as multiplying by the reciprocal. Cancel the 2's, you get negative root 3. That's the tangent of 5 pi over 3.